On April 16, 1945, Soviet forces began their final assault on Berlin with conventional 152mm howitzers that could not reliably collapse the reinforced apartment blocks and concrete bunkers that German defenders had transformed into fortress positions throughout the urban battlefield. Within 16 days, the city lay in rubble, demolished block by 870 tracked howitzers, firing 100-kilogram shells that could lift entire buildings before they collapsed into debris. The weapon that achieved this systematic destruction had originated 15 years earlier from a recognition that modern warfare demanded artillery capable of delivering single-shot devastation against fortified positions that conventional field guns could not penetrate, a requirement that would transform crude engineering into the sledgehammer that broke the Third Reich's final stronghold. Contemporary European defensive systems featured reinforced concrete positions designed to withstand direct hits from standard artillery. The Finnish Mannerheim Line, with major construction during the 1930s, incorporated bunkers with concrete walls up to 2 meters thick and steel-reinforced observation posts. German experimental fortifications at Kummersdorf employed reinforced concrete exceeding 3 meters in thickness. Soviet artillery planners recognized that existing weapons lacked the projectile mass and explosive content necessary to achieve reliable destruction of such positions. The need intensified when Soviet military observers analyzed artillery limitations against fortified positions during various conflicts. Republican forces, equipped with Soviet 152mm guns, demonstrated the challenges of reducing fortified positions despite sustained bombardment. Field reports indicated that concrete bunkers withstood dozens of direct hits from standard high-explosive shells without structural failure. The lesson was clear. Future offensive operations would require artillery capable of delivering massive, single-shot destructive effects rather than sustained bombardment with lighter projectiles. The Artillery Committee commissioned development of a 203mm howitzer with extended range capability in 1930. The commissioning decision specified a development timeline and mandated a tracked carriage utilizing tank track systems to enable firing from unprepared positions. The project appointed B.S. Burdejko as chief designer at Factory No. 92 in Gorky, recognizing that the project demanded expertise in both artillery design and heavy mechanical engineering. Burdejko's design philosophy emphasized maximum destructive effect over rate of fire or mobility. The 203mm caliber was selected after rejecting competing proposals for 210mm, 152mm and 180mm designs. The 210mm variant promised greater projectile mass but required excessive barrel weight that compromised carriage design. The 152mm option offered superior mobility but delivered insufficient explosive content for reliable concrete penetration. The 180mm compromise achieved neither adequate destructive power nor acceptable weight characteristics. The design team completed the howitzer by 1931 under Burdejko's direction. The Factory No. 92 Design Bureau incorporated the tracked carriage concept that reflected Soviet industrial capacity in tractor production, and provided the stable firing platform necessary for the weapon's massive recoil forces. The design incorporated lessons from Soviet tank development, employing track systems that distributed the 17.7 metric ton weapon weight across sufficient ground contact to prevent sinking in soft terrain. If you're interested in how industrial capacity and engineering doctrine shape military outcomes, subscribe now and turn on notifications for more deep dives into the weapons that decided history. The 203.2mm bore delivered a 100-kilogram OF-530 high-explosive projectile containing 6.5 kilograms of TNT at 600 meters per second muzzle velocity. The barrel length measured 4.894 meters, equivalent to 24.1 calibers, providing sufficient acceleration distance for the massive projectile while maintaining manageable recoil characteristics. Maximum range reached 18,000 meters at 60 degrees elevation, though the weapon's primary role emphasized direct fire at ranges under 1,000 meters. The tracked carriage weighed 17.7 metric tons in firing position and employed a hydraulic recoil system capable of absorbing the substantial forces generated by the 100-kilogram projectile. The carriage design featured a split-trail configuration with a cruciform firing platform that provided stability during maximum charge firing. Traverse was limited to 8 degrees from centerline, requiring repositioning of the entire weapon for significant directional changes. The elevation mechanism permitted angles from 0 to 60 degrees, enabling both direct fire against visible targets and high-angle indirect bombardment. Rate of fire was constrained to 1 round per minute sustained, reflecting the manual loading procedures required for the 100-kilogram projectile and separate propellant charges. The 10 to 12-man crew included gun captain, breech operator, loader, ammunition handlers, propellant charge specialist, gun layer, sight setter, and maintenance personnel. The weapon employed a 12-charge propellant system ranging from 3.24 kilograms for minimum range to 15.0 kilograms for maximum velocity and penetration. Manufacturing complexity limited production to specialized facilities. Each howitzer required substantial skilled labor and high-quality steel. The barrel alone demanded precision boring and rifling operations using heavy machine tools available only at premier artillery plants. This technical profile established the B-4 as a strategic weapon rather than a mass-production field piece. Soviet forces employed B-4 howitzers for indirect fire support against Berlin's fortified positions during the operation from April 16 to May 2, 1945. The 8th Guards Army deployed the weapons in support of infantry assaults, utilizing both indirect fire doctrine and occasional direct engagement of visible targets. Soviet doctrine called for positioning the tracked howitzers in concealed positions for bombardment of German strongpoints throughout the urban battlefield. The systematic bombardment pattern was devastating. A single 100-kilogram OF-530 shell could collapse entire apartment blocks, achieving high effectiveness rates in bombardment roles. During the final assault phase, Soviet artillery expended substantial quantities of 203mm ammunition against the Reichstag, destroying upper floors and forcing German defenders to retreat to basement levels. The 8th Guards Army fired extensive rounds during the operation, despite logistical constraints in urban terrain. Soviet tactical employment utilized conventional artillery doctrine. Soviet crews positioned howitzers in concealed locations for indirect bombardment, while occasionally advancing the B-4 for direct engagement of target buildings. Tracked carriages enabled movement through debris-filled streets, where wheeled artillery would have become immobilized. The weapon's ability to fire from unprepared positions eliminated the time-consuming emplacement procedures required by conventional heavy howitzers. German defenders in the Tiergarten and Königsplatz sectors faced systematic destruction of their prepared positions. Fortified apartment blocks that could withstand sustained machine gun fire and tank shells succumbed to B-4 impacts. The psychological effect complemented the physical destruction, as German troops recognized the vulnerability of defending positions subject to heavy bombardment. Soviet infantry followed B-4 bombardment with immediate assault, preventing German forces from reoccupying damaged buildings or establishing alternative defensive positions. German 56th Panzer Corps war diaries documented the B-4 among the most effective Soviet weapons encountered during the Berlin operation. Captured unit records describe blast effects powerful enough to cause loss of consciousness from concussion alone, even among defenders not directly struck by projectile fragments. German counter-battery fire proved ineffective due to the B-4's concealment capabilities and Soviet artillery coordination in urban terrain. Prisoner interrogation reports confirmed severe psychological impact on German defenders. Wehrmacht personnel described the weapon as capable of lifting entire buildings before they collapsed into rubble. The weapon earned recognition for its crude but devastatingly effective approach to urban warfare. German commanders ordered withdrawal from upper floors to basement strongpoints, acknowledging that exposed positions were indefensible against B-4 fire.
German attempts at tactical adaptation failed to counter the weapon effectively. The 56th Panzer Corps attempted to locate and suppress B-4 firing positions using remaining artillery assets, but Soviet crews repositioned frequently and employed effective camouflage in the urban environment. German defensive doctrine had not anticipated artillery employment at such intensity, and existing counter-battery procedures proved inadequate against weapons firing from concealed positions within the city itself. The Wehrmacht's recognition of B-4 effectiveness appeared in tactical reports describing the weapon's impact on defensive planning. German commanders abandoned attempts to hold fortified buildings in sectors where B-4 howitzers operated, instead concentrating forces in underground positions and basement strongpoints less vulnerable to bombardment. This tactical shift compromised German defensive coherence and accelerated the collapse of organized resistance in central Berlin. Soviet production achieved approximately 870 total B-4 howitzers manufactured from 1931 through 1941, primarily at Factory No. 92 in Gorky. Each weapon represented substantial industrial investment. Production reached significant levels during pre-war years, representing multiple howitzers monthly at maximum output from the Gorky facility and other manufacturing plants. Manufacturing demanded substantial material commitment. Each B-4 required high-quality steel and skilled labor. Steel costs alone represented significant material investment per weapon, consuming high-quality material suitable for artillery barrel production. The barrel forging and precision machining process required specialized equipment available only at premier Soviet artillery plants. The economic comparison reveals strategic priorities. While Germany produced 1,347 Tiger tanks total, at substantial manufacturing investment each, the Soviet Union built hundreds of B-4 howitzers at lower cost per weapon. The arithmetic favored Soviet production philosophy: adequate weapons manufactured in sufficient quantity, rather than perfect weapons produced in limited numbers. Each B-4 cost substantially less than a Tiger tank's manufacturing investment, while delivering comparable destructive effect against fortified positions. Total pre-war B-4 production represented substantial investment, demonstrating Soviet commitment to heavy artillery capabilities. The Gorky facility operated multiple shifts daily, with thousands of workers during peak production. Quality control maintained standards with minimal completed howitzers requiring rework before acceptance. This production achievement occurred despite material constraints and the facility's distance from frontline operations. The B-4 remained in Soviet service until the mid-1950s, with substantial units maintained in post-war inventory. Limited export may have occurred to Allied nations during the post-war period, though exact numbers remain undocumented in accessible sources. Export to Warsaw Pact nations was limited, as the weapon's weight and slow rate of fire made it less suitable for standardized alliance doctrine. The Soviet Union retained heavy artillery capabilities, rather than distributing them extensively to Allied forces. Modernization efforts included experimental self-propelled variants, which suffered mechanical challenges from recoil forces. The weapon was superseded by nuclear-capable artillery systems and more mobile self-propelled guns during the 1950s and 60s. Retirement reflected broader Soviet artillery doctrine evolution toward mechanized warfare and rapid deployment capabilities incompatible with the B-4's operational characteristics.
The heavy howitzer that demolished Berlin block by block achieved its purpose through relentless adequacy rather than technical sophistication. Simple enough to manufacture under wartime constraints, effective enough to justify strategic resource allocation, durable enough to outlast the conflict that created it. The weapon succeeded not through innovation, but through systematic application of overwhelming force at decisive moments, embodying Soviet military philosophy that emphasized practical solutions over elegant engineering. Hit subscribe for more World War II deep dives, examining how industrial capacity and tactical doctrine determined history's outcome. Thanks for watching.